Aloha. All right. So this is the domain and range video from our class 18 here. So you should have already checked the document from the last class, and you should have already watched the solution video from class 17 on the decay and growth models. And after you finish watching this video, then you will go on to complete page 19, and you'll be working in either one of the quiet rooms, or the quiet room, or one of the group working rooms if you want to have your camera on and talk. And when you finish with page 19, then you can move on to the done and ready room. If you have any questions, hit that little ask for help button along the way. So in this video, we're talking about domain and range. So we've already been this, we've already tested on it, so it's going to be kind of a quick video, hopefully. So the first thing that we have is domain. So some of the other things that we have for domain, we say that this is the input. So what values can I plug into my function? And specifically, we were talking about the x values here. So which x values can I plug in? And when we're writing up our domain and range, we're going to be using interval notation. So interval notation is looking from a low point to a high point. And when you're talking about the domain, this is the x-axis, and the x-axis runs left to right. So we're going to say how far to the left does my graph go, how far to the right does my graph go. The range, again, so the range is what you can get out. So x is what you put in, and y, the y values, is what you get out. That's the range. And the y-axis runs up and down. Well, we always go from low to high, so we would be looking at how far down does my graph go to how far up does my graph go, down to up. And the x-axis, I was going to say this runs left to right. There we go. So this one is something that I just made up. It's not a unit packet, just to give you something concrete to go off of, because the rest are all exponential models. So this is a linear model here, well, part of a linear model. It doesn't go on forever. You can see that this line stops here. So for your domain, you're looking at the x-axis. How far left and right does my graph go? So like can I plug in 0 for x? Yes, I'll get 3 as an output. Can I plug in -1? Yes, I'll get, I don't know, 3 point something, 25 as an output. Can I plug in -2? Yes. -3? Yes. -4? Yes. Can I plug in -5? No. My graph doesn't go over here at all. My graph stops actually at -4. So on the x-axis, that's the farthest to the left I can go, is all the way to -4. And then how far to the right does my graph go? Well, my graph will go from -4 all the way over to 8. That's the furthest to the right my graph goes. So those are the things that we're looking for. Domain is your x, your input, and that's going from left to right. So the farthest left is -4, the farthest right is 8. Now for interval notation, we usually will have either a parenthesis or a bracket on the side. So if you're going to be including your endpoints, so if your endpoint is legit, you're going to be using a square bracket. If you are excluding or not including your endpoints, that's going to be where you use a parenthesis. The way you know that you're included or not is if you have a filled in circle. If you're excluded, you have an open circle. So here we're going to be using brackets, and here we're going to be using parentheses. So at -4, it is a filled in circle bracket. At 8, it is an open circle parenthesis. The range is your y-axis, and this is, again, running down to up. I forgot the left to right again. So looking at this, on the y-axis, what's the lowest value that comes out of my graph? Well, my graph has a low point all the way down over here, and again, when you're looking at the range, this is the y-axis. This is my lowest point all the way down at 1. What's my highest point? Well, my graph goes all the way up to here, which is over at 4. So my graph is squeezed in between 1 and 4. Now the low point here at 1 is an open circle, and the 4 here is a bracket because it's a filled in circle there. So my range is from 1 to 4, not including 1, but including 4. So here, these ones are finally in a unit packet. This is on page 18. So we're looking at this, and again, we're going to assume that these are, they should have had arrow points on here. So I'm just going to throw those in as well as I'm seeing it right now. So domain and range for these things. So again, domain is the x values. This is my graph running left to right. How far to the left does my graph go? How far to the right does my graph go? Just by looking at it, this thing is going to keep going up and left, up and left, up and left. Bottom line is that it keeps going left. Very slowly, but it does keep going left. Like when I plug in 0, I get something. When I plug in -1, I get something. When I plug in -2, I get something. When I plug in -3, I'm going to get something. It's way up here. If I plug in -4, I'll get something way off the map. So I can go all the way to the left, which is like negative infinity. And with infinities, you always have a parenthesis because there's no endpoint. And then how far to the right do I go? And I can go all the way. The arrow means it's going to keep going forever and ever. So this is negative infinity, positive infinity. You can also say all real numbers. That's fine with me. Otherwise, the funky R symbol, that's cool too. And then, but the range here, this is where it gets different. So for exponential functions, that you will have, you will see a restriction on your range. So the range is your outputs. How far low, how far down does my graph go, and how far up does my graph go? Well, I'm going to answer the second part first. How far up does my graph go? I was saying it before over here. Again, I'm going to get 3, almost 6. I'm going to get 12 something, 20 something, 30 something, and my graph goes up forever and ever and ever. The highest point of my graph is infinity. Graph booms up to the right. But the lowest point, as I move into the right here, I'm getting 2, I'm getting 1, I'm getting a half, I'm getting a third, a fourth, a fifth, a sixth, a seventh. And you can see that my graph kind of just levels off here, and it doesn't ever go below this line. That line is called our asymptote, and it goes all the way down to 0. Now it will never cross. There's no graph below in the negative zone here over here. So 0 is the lowest point my graph goes, and it goes all the way up to infinity. For the next one, domain. Domain is my x values. How far to the left does my graph go? The 0 means it goes forever left. How far to the right? It's going down and right, down and right, down and right. Slowly, but down and right. Shocker, it's going to be negative infinity to infinity. You're going to see that for all the domain. But the range is where it's important here. So again, the range is the y-axis. This is your down to up. How low does my graph go? Well, my graph goes down. We're looking at the how far low does it go? It goes all the way down to negative infinity. And it goes all the way up, and then it doesn't get any higher than this point right here. It doesn't get any higher than 0. So as you're going to the left now, like it gets up, and then it doesn't ever cross over the x-axis into the positive land. It's going to stop at 0. Same page, bottom 2. So domain and range for these guys. That's like the same graph. Okay. Oh no, it's shifted up a little bit. Haha. All right, so domain, again, is your x. How far left does my graph go? Oh, I'm going to add these arrow points on here. This thing will go forever to the left, so negative infinity, and it will go forever to the right, so going to the right all the way and left all the way. So this thing goes down and right, down and right, down and right. It moves to the right very slowly, but it will keep moving to the right. Your range is the good one to note here. Just want to delete this out of the way. Again, your range is your y-axis. How low does my graph go? Well, my graph will go forever down, but as it goes up, you see that it reaches a stopping point here at 5. The highest my graph goes is at 5. It doesn't go above that line. So it's from negative infinity all the way up to 5. And for this last one here, domain is, again, negative infinity to infinity. It goes all the way left, all the way right. But the range is where it's different. The lowest point, you see, as I'm kind of working my way to the left, the lowest point my graph goes is whatever this value is. This looks like it's at 2. So that's my lowest point in the graph. And the highest point, how far up does my graph go? All the way up to infinity. So you're going to be seeing that your range is the one that you're going to have these restrictions on, and that's going to be determined by your asymptote. Lowest point of 2. That 2 you're going to see in your formula. Highest point of 5, you're going to see that in your formula. So that's what you're going to try to identify when you do this. So I want you to move on to the next room after I finish this little skit up and work out some of these problems, or work out all of these problems on this, and be able to answer the questions that are directly below it right here. So I'll kind of show you what I'm looking for, and I also would like you to do a quick sketch. So go open up Desmos and 6 1/3 to the x. So if I go open up Desmos, I'm going to type f of x equals, you don't really need to type that, but that's all right, 6 parentheses 1/3. You have to get out of that, click or whatever, shift 6 to go up here, 1/3 to the x. And if you look, here's what that graph looks like. So it goes up forever and it levels off at 0. And left and right it goes all the way. So back on here, so this is kind of what my graph looks like. It looks something like this. So my domain is negative infinity to infinity. My range, the lowest point my graph gets, Well, again, it's getting closer and closer and closer to that, so the lowest point is 0, and then how high it goes is all the way to infinity. So do something like that. Graph all these in Desmos. So open up Desmos.com and click on their graphing calculator. Do a quick sketch for me and for yourself for like later reference. So get some graphs drawn on here for all of these ones, and then be able to answer these questions. So I will be asking many people these questions, so I'll be able to answer it. I had a little thing in here. We're talking about the base here for that problem. And if you're done early, you can move on to page 20 or 21. All right, so we'll call this video over. Get working on that. If you have any questions, make sure you ask for help. Thank you.